Hello, my little triglets. Welcome to Trigonometry Online. So today we are going to start with section 3.1, and it has to do with angles and rays and degrees and things that you're already familiar with. So just to get a couple things out of the way, the definition for angle is when you rotate a ray about its endpoint. So if I take a ray and I rotate it, it's going to make this angle here. And in this class, we name angles with Greek letters. This Greek letter is pronounced theta. Theta, we'll be using that quite a bit. If I were to draw a ray, most of our rays are going to be on the x-axis in the positive direction, and we are going to go upward in a positive direction. And this becomes the angle we're talking about. This is the terminal side. Okay, this is the initial side. So when I say initial side and terminal side, those are what I'm talking about. And clockwise, counterclockwise. You guys are used to digital clocks, but counterclockwise is going against the clock. Clockwise is going with the clock. So when I say counterclockwise, it's actually going to be a positive angle. If I say counterclockwise is positive, clockwise is going to be a negative angle. So let's start again here. We've got our grid, and I'm going to go 90 degrees. That's a positive 90 degrees. We don't put the plus sign, but just for learning purposes, we'll put it here. If I go this way, this is going to be negative 90 degrees. So clockwise, counterclockwise. If I ask you what's 3/4 of a rotation around the circle, counterclockwise. See if you can figure that out. 3/4 of a rotation counterclockwise. That's going in this direction, and you want to go 3/4 of the way around. Where are you going to end up? Well, if I continue this, there's half, there's 3/4. It's 90, 90, and 90, so that's 270 degrees. Not so bad. If I ask you what's 1/2 of a rotation clockwise, that's in the other direction, halfway, what are you going to put? In this direction, it's going to be negative, and halfway around is going to be 180, so negative 180. See if you can figure this one out. 11/6 of a rotation counterclockwise. I'll give you 5 seconds. Do, 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 do. Okay, time's up. What did you get? Hopefully you got 660 degrees. If you did, pat yourself on the back. That's awesome. Okay, how about if you had an hour hand on the clock and it goes, everybody knows it takes 12 hours to go around once. How many degrees is it for 9 hours? So think about that. It's 9 hours out of 12. You can just say 9 out of 12 is 3/4, and we already did 3/4. Came out to be 270 degrees. And we don't, this one's not asking for clockwise or counterclockwise, so we don't need to worry about that. We just make it that many degrees. Now, you know that the clock has hours, minutes, and seconds. But if we're talking about a circle, we talk about degrees, minutes, and seconds. It's kind of the same concept. The degree we write as 1 degree. A minute in math is 1/60th of a degree. and seconds in math is 1/3600th of a degree. So 60 times 60. So if I have 36 degrees, 50 minutes, and 10 seconds, this is a very, very minute measurement. It's very, very, accurate. We're going to break this up. We're going to say it's 36 degrees, and then we have 50 out of 60 minutes, because every minute is 1/60th of a degree, and then we have 10 out of 3600 seconds because of this rule here. So if I add those all up, do it on your calculator, and make sure you're rounding. Let's round to the nearest thousandth. So I get 36.836. So 36.836 of a degree. So if you're a surveyor, you measure it like this out on the property, but when you go to figure out calculations, you use the decimal equivalent. Now, we did that forward. We went from degrees, minutes, seconds, degree, minutes, seconds, and we went to decimal degree. So we're going to go the opposite. We're going to go start from decimal, and we're going to go to degree, minutes, seconds. So if I take 50.525 degrees and I convert it to degree, minute, seconds. Well, I already know that it's 50 full degrees. Then I take the decimal equivalent of 0.525 and I want to multiply it by 60 minutes. So I multiply that out and I get 31.5 minutes. So I've got 50 degrees, then the full minutes are 31 minutes, and then I have this much that I'm going to multiply by 60 again, not 3600, because 60 times 60 is the 3600. But this will multiply it by 60 seconds, so 0.5 times 60 is 30. So that gives me my 30 seconds. So it's a little bit different going from one to the other, forwards and backwards, but keep in mind that it's 60 times 60, and that gives you the 3600. Okay, there's one more definition you have to know. Coterminal. Coterminal, like if you're a captain on the basketball team, there's two of you, you're called co-captains. You have the same job, but you're a different person. This means you have the same terminal side, but it's a different angle measure. Now, for some reason, kids have a hard time with this. You gotta make it as easy as it is. If I have, this is 45 degrees. Okay, so 45 degrees. If I went all the way around the circle, and let's make it a different color here. If I go all the way around and come back to that same terminal side, how much more did I go around? I went one full circle more. So if I add 360 to this, add 360 and 45, I get 405 degrees. 45 and 405 are considered coterminal. Terminal. I gotta learn to spell. Then if I add another color, and let's say I go in the opposite direction. Let's say I start here and go this way. Now I just went negative. I didn't go all the way around, almost all the way around, minus 45 degrees. So that angle is 315 degrees, but in the negative direction. So this is another coterminal angle with the other two. So all of these, 45, 405, and 315 are considered coterminal. They all land on this terminal side, but they all have different measures. So an easy way to do this is to take your angle, whatever it is, and add or subtract 360 degrees to get a coterminal angle. You just keep adding 360 or subtracting 360, and that will get you another coterminal. Couple quick reminders, the stuff you've known, but maybe you've forgotten. If you have your quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And remember, this is positive and it's counterclockwise. This is negative and it's clockwise. I think that is all I need to tell you for today. Your practice problem right now is I want you to find 3 coterminal angles of 30 degrees. You do that and you bring it to class tomorrow, and that is it for tonight. Have a good evening.